All right, so the first half of 2-3, we are going to look at polynomials of higher degrees. So in the last section, we only looked at degrees of 0, 1, and 2. So now we're going to look at degrees of 3 and higher. So I've drawn for you 4 different pictures. And from those pictures, you can determine whether it's an odd or an even degree function, all by looking at the left and the right-hand behavior. So as I look at this, and I know that I've drawn it so it looks like a parabola. The dotted part is just what the graph might look like. So with parabolas, that was an even function, wasn't it? This is the second degree. Notice that the left and the right-hand behavior agree. They're both going up. This was an even function. Even functions, they both go up. And so you might want to write here, even functions, left hand and right hand agree, meaning they both go in the same direction. Whereas with odd functions, so if you think of your most common odd function, which is the cube function, doesn't that look like an S? Right and left hand go in opposite directions. So for your odd function, left hand and right hand do not agree. That's supposed to be separated. Do not, it's really not together. It's not donut. So look at the second picture. Isn't your left and your right hand disagreeing? One's going positive, one's going negative. So that means this is an odd function. So you name the other two. These two agree, right? So this is an even function. And these two agree. So it is another even function. What can you tell me? What do you propose about this function? Anything that you've learned from the past that we can use here? Why do you think it's x to the 4th? Very nice. Did you hear what he said? He said this is probably an x to the 4th. It could be because it intersects the x-axis 4 times, which means it has 4 zeros. So at a minimum, it's an x to the 4th. It's possible it could be an x to the 6th. Possible. But at a minimum, it's an x to the 4th. And so x to the 4ths tend to look like this W shape here, upside down. This is not quite a W, bless you. But I want you to notice that this also is an x to the 4th, but it only crosses the x-axis twice. Just remember that at most an x to the 4th, we could have 4 zeros, and sometimes zeros are imaginary, and imaginary zeros come in pairs, don't they? So on this one, it only crossed the x-axis twice. That means that there must be 2 imaginary zeros up here somewhere. This one's up, this one's down. What does that tell you? Not an inverse. What did we learn day before yesterday about something causes the graph to turn upside down? A negative where? In front of the leading coefficient, right? And the leading coefficient doesn't mean that it's the first term in the polynomial. It means it's attached to what term? No. How about the highest degree term? Right, the highest degree term in a polynomial is what names the degree of that polynomial. So we'll look at that here in a minute also. All right, so we did a lot, or I've introduced you a lot to limits, notation with left and right hand behavior. True? You're going to see that in this homework a lot today. So leading coefficient tests dictate right and left hand behaviors of a graph. So let's go ahead and look at that. So the first graph is probably what kind of graph? Even or odd? Odd. So this is an odd graph because you've got left and right hand going in opposite directions. To determine whether the leading coefficient is positive or negative, always look at right-hand behavior. The right-hand behavior is the easiest to look at to determine if that leading coefficient is positive or negative. So on this one, the right-hand behavior is up. And if you think about the normal cubic functions, this is an S-curve, so it's probably a cubic function, and it crosses the x-axis 1, 2, 3 times. So it's probably to the third degree. Doesn't the normal cubic function start in the upper right and go to the lower left? So the right-hand side is going towards positive infinity. And isn't the leading coefficient on y equals x squared, or sorry, y equals x cubed, isn't the leading coefficient to positive 1? True, right? So this is no different than that general basic graph of y equals x cubed. It's just got some hills and valleys in it. And what causes hills and valleys are additional terms, like there's probably an x squared term in there and an x term in the polynomial in addition to that cubic term. They're all thinking, do you have one for us? We'd like to have one too. Each to his own, right? So based upon this, I can tell you that the leading coefficient, and your textbook likes to name the leading coefficient as a sub n. N tends to be the degree of the polynomial. So I know that the leading coefficient is positive, greater than 0, because that right-hand behavior goes up. So we can actually write the limits. In addition to that, just by looking at the graph. So get used to writing your limits. The limits, as x approaches, for right-hand behavior, x approaches what thing? Always, for right hand. Going to the right, x is approaching what? Positive infinity. Of f of x equals, bless you. In this graph, what is the graph doing on the right-hand side? Is it going up or down? Going up, bless you, is positive infinity. So there's your limit showing the right-hand behavior is positive infinity. Your left-hand behavior, going right down here, the limit as x approaches negative infinity, because going to the left is negative infinity. So those never change. The minute I see that x is approaching negative infinity, I know we're talking about left-hand behavior, because that's the left side of the x-axis. Of the function, what is this function doing? On the left, it's going down, so isn't that negative infinity? Well, look at this one. Even or an odd function. So this is odd, just like the previous one. But look at the right-hand behavior this time. The right-hand behavior tells you that the leading coefficient is what? A sub n is negative because this is going down, so it's less than 0. Yes. I put just f of x instead of x cubed because I don't know what the exact function is, because, for instance, it could look like this one down here, right? I don't really know because I have this kind of fuzzy part in here. And so the best I can tell you is it is probably a cubic function. And I know that the leading coefficient is positive. So at this point, that's all I can tell you. And I can tell you what the right and left hand behavior are because I see it there. No, that's a good question. And then in your homework, you'll see that they give you some very long functions. You will have to put the long functions in there. You can shorthand right now doing f of x rather than having to write it out each and every time. So our limits on this one, this is the last one that we'll do limits on. The other two we won't do on. So the right hand limit here, so the limit as x approaches what? I'm going right hand. Yeah, but I want to know what my notation is here. I'm going to the right for x. So that's positive infinity. Of the function equals, now what does it equal? 8. It goes down, so negative. Remember that this is attached to the x, so this tells you what direction on the x-axis we're going. Since I'm right-hand behavior, we go towards positive infinity. The other side, the equal sign, is always your output, or your y. What's happening to the y? The graph is going either up or down. And so because it's going down, that's why it's negative infinity. Left-hand behavior. So the limit, as x approaches what this time? Negative infinity of the function is equal to, what's the graph doing on the left this time? Positive infinity. So then I want you to decide what's happening in graphs 3 and 4. Is it an even or an odd function? Is the leading coefficient positive or negative? And then I'm not going to make you write the limits on these ones. So you don't have to do those two. Even or odd, and what's the leading coefficient going to be? A sub n. No, that's what we're using. And what do you look at to determine whether the leading coefficient is positive or negative? The right-hand behavior. Very helpful. Are you ready? All right, so the third one is even because the left and the right hand are going in the same direction. And because the right hand is going towards positive infinity, we know that our leading coefficient is positive. The second one is also even. And because the left and right hand agree, but the right hand is going towards negative infinity, I know my leading coefficient is negative. So that's clear, yes? Okay. Then we're going to find the behavior without looking at the graph and without plugging this into our calculator. So now we're looking at just the equation, no graph. So f of x is equal to 2x cubed minus x squared. What is the power of this function? 3. And I get that from looking at this term, not because it's the first term, but because it's the highest degree term. So I know that in general, these tend to look like an S-curve. Is my right hand going to be going towards positive infinity or negative infinity? Because I have a positive leading coefficient, my graph should be looking like this, correct? And I want to envision what my sketch of my graph looks like so that I can write my limits, because they're asking for me to find the behavior. That's your left and right hand behavior. So we are going to write our limits for each one of these. So our limit, let's do right hand behavior. So x approaches what? On the right. Always positive infinity for right hand. Of the function, here's where you're going to see me writing f of x. Your book's going to want you to write 2x cubed minus x squared. I'm being nice. Let's not write all that. So the limit of that function is equal to, without even using my calculator, I know that the right side is going up. So it's going to positive infinity. And then my limit for the left-hand behavior would look like what? X approaches. What's the left side of the x-axis? Negative infinity of the function. What's happening on this graph on the left side? It approaches negative infinity. So notice that with an odd function, your left-hand and right-hand behavior should not agree, and it doesn't. Because our leading coefficient is positive, our right-hand behavior is positive infinity. So now I want you to do the next two on your own. Follow what we did up here, using knowledge, is it even or odd, and what is the leading coefficient? Draw a quick sketch. Well, let's just start on number 2 with just a quick sketch, so you get that right, so you don't get your limits wrong. Draw a sketch of what you think negative x cubed plus 2 might resemble. Here's your sketch. Doesn't it look like that? So this time, your right-hand behavior should be going down. So now do your limit for this one. And we'll check it before you do number 3's limits. Do your right-hand limit first, and then your left-hand limit. So compare that with somebody around you. See if you guys agree on the left and right hand limits. Are you talking to Logan? Why not Brady?
Brady has Eli.
Okay, so here's your limits. This is your right-hand limit because x is approaching positive infinity. So on the right, the graph is going down. So the right-hand behavior is negative infinity. This is identifying my left-hand behavior because to the left is negative infinity on the x-axis. So the left side of my graph is actually going up. The left-hand behavior is positive infinity. How would you do with that? You've got about 3 or 4 questions that you have to do this on. All right, look at the last one. I want you to just sketch the graph first, determine if it's an even or an odd function, whether, and then determine what the right-hand behavior should look like to help you with the left-hand behavior. So draw your sketch. You have your sketch. Is it an even or an odd function? Even. Does that mean that the left and right hand agree or they disagree? They agree. So are they going both up or both down? Both down. So this should probably look something like a W. And then note that your right hand is negative because you have a negative leading coefficient. So now do your right hand behavior first, then do your left hand behavior. So right hand behavior, left hand. Okay, is that right?
Sweet.
That's good to know.
Yeah. Sweet. I might use that word there.
So once you get the sketch and you understand the notation can be very quick to do, right? All right, so here we go. Because it's an even function, the left and right hand behavior need to agree on the answer part of that notation. And because it's both going down, both of these are negative infinity. These, however, remain positive infinity meaning right hand, negative infinity meaning left hand. Mr. Hayes. All in the city. All right, flip it. Any questions on that before we move on? Okay. So extrema, which Mr. B from Mr. E, extrema, and zeros. You're just going to find in general about how many extrema could there be and about how many zeros. For this particular question, you're not actually finding the exact zeros and the exact extrema because we're not using a calculator. But you have to kind of know about how many times could it cross the x-axis and about how many hills and valleys could we have on the graph. And so the following is what we tend to go by. So write this above here. A polynomial function of degree n, so that's why we had a sub n, of degree n has at most, and that's a very important phrase, at most, n minus 1 local extrema and at most, again important phrase, n zeros. You always have one less extrema than you have zeros, or a possibility of that. Notice it says at most because imaginary numbers can create fewer extrema and fewer zeros. As soon as you have that written down, we're going to look at the first page again and explore this. Well, hang on, we're not getting to that yet. So let's look over here. So look at our even function here. We proposed that it was to the 4th degree because Mr. Buckman said it went here 1, 2, 3, 4 times, right? So if I have 4 zeros, I always have one less number of extremas, which are our hills and our valleys, our highs and our lows. And so how many hills and valleys do I have here? 3. So 4 minus 1 is 3. That makes sense, right? Same thing here with the odd function, which we proposed was a cubic. I have 1, 2, 3 zeros there, but I only have 1, 2 hills and valleys, correct? That's our relative max and relative mins. So, let's look at the problem at hand. What is the degree of this polynomial? So we have a degree of 3, and again, not because that's the first term. So our degree equals 3. Leading coefficient has nothing to do with this. That has to do with left and right hand behavior. What I'm going to find are my zeros first. At most, how many zeros do I have? At most, I have 3. You kind of need to use the word at most because I might not have 3. I could have 3 zeros or less. Could I have just 2 zeros if this is a cubic? Because if I had just 2 zeros, that leaves 1 being what? Imaginary. Can only 1 zero be imaginary? What did you learn about imaginary zeros? They come in pairs. So I can't have 2 zeros that cross the x-axis, right? I can have 3 zeros or 1 zero because if my imaginary come in pairs, they take up 2 of them, right? And that leaves only one place to cross. So do bear in mind that your imaginaries come in pairs. And then our extrema would be at most 3 zeros minus 1, so that's going to equal at most 2. I don't have to have 2, but at most I'm going to have 2. 1 hill, 1 valley. So I want you to do number 2. Oh, we could actually sketch this graph. Let's do that before we do number 2. So I can kind of sketch this graph. It's not going to be perfectly accurate. But if I know I have 3 zeros at most, that means, oh, if I'm going to cross it, I don't know, 3 places along the x-axis. I do know, because I can see the function, that my leading coefficient is positive. And it's an odd function, so I have a left and a right-hand behavior that disagree, meaning one's going up and one's going down, or one's going down and one's going up. On the right hand, where do I start? Do I start up or down? Why up? Positive leading coefficient. So if I start up, and I hit that 0, then I have to go down into a valley, I have to go back up and hit the next 0, I go up into a hill, hit the next 0, and then I'm going down. So I could kind of sketch that and do a fairly decent job of it. I don't know how high or low my hills and valleys are. We'll determine that later. Now you do number 2 and also sketch the graph of what you think it looks like. So find the zeros, work off the degree first, but find the zeros. And make sure you sketch it. And compare your answer to those around you. It's always 1 less than, look at the very top where you wrote, it's always 1 less than your zeros. No, your terms can't be negative. It's just counting. There has to be a positive.
Oh, 3 minus 1. Okay, no, I see now. Okay,
Yeah. Did we come up with a conclusion? what's the degree of the polynomial? 4. So how many zeros? At most 4, right? You don't want to just say 4, so you want to say at most. Because it could be less. A 0 means it crosses the x-axis. If it's an imaginary answer, it won't cross the x-axis. And I'll teach you on Monday how to determine that. So extrema. At most 3 because it's 1 less. So here would be what your sketch would also look like, give or take. Because my leading coefficient is positive, I know that, and it's an even function, I know that the left and right hand have to agree, and therefore they have to both go up because the leading coefficient is positive. So you good with that? You're just doing some detective work, using your knowledge and have an idea of what that graph looks like. Then on example 5, this is the last example we're going to do today, and don't get industrious and do part 2 on your own because I'm changing that question. So we're finding our zeros algebraically, and then we're going to graph by hand. Now each one of these has max and mins to them. It does not say find the relative max and min. So we're going to estimate a relative max and min. Now with a parabola, which is what this quadratic is, we do know how to find the vertex, don't we? We could either put this into vertex form by completing the square. And actually, completing the square is a whole lot quicker once you're very good at completing the square than using the quadratic formula, to be honest. And it's much easier to see that vertex, because it's going to end up being a fraction when it's in that vertex form. But they didn't ask for that, so we're not going to do that. We are going to find the zeros. How do I find the zeros? How? What do I let what equal? And not 0. I want to let y equal 0, and in this case, y is what? F of x. So we're going to replace f of x with 0 because the value of y on the x-axis is always 0. So we're letting f of x equal 0, and we're going to factor this quadratic if possible. So we're going to take 1 times 28. That gives me a positive product of 28. Because it's positive, we're adding the factors of 28. We are looking for our middle term of 11. What factors of 28 add to give you 11? So 4 and 7, they do indeed add to give you 11. Our 11 is negative, so the bigger of the two carries that same sign. So the 7 becomes a negative also. What does the 4 have to be? Positive. If the 4 is positive, then these add to give you negative 3. So I want the 4 to be negative also. Because the coefficient of the squared term is 1, I don't have to use group and garbage. I can just take this trinomial and break it into two binomials. The x squared becomes x and x, and I put my minus 4 and my minus 7 in there. If the squared term had a coefficient in front, you'd have to go through the group and garbage and group and take out GCFs and all that kind of stuff, right? Or if you don't know how to do that, quadratic formula, or completing the square, right? Will completing the square, by the way, solve and find the zeros for you? No. So if my goal is to find the zeros, I don't think I'd be completing the square. So your only choice here is quadratic formula or factoring. And so if you set each one of these equal to 0, then you get x is equal to 4 and x is equal to 7. Does this parabola open up or down? So we know that it opens up. And because it's an even function, the left and right hand should agree. So I ought to be able to sketch my graph. And you'd be able to go to 7 on the x-axis. So I'm going to plot a point at 4 and a point at 7. Because I know a parabola is symmetrical, I want to find the very middle between these 2 points. What's the distance, or what's the midpoint between 4 and 7? 5.5, right? So it's right here in the middle. I'm going to actually draw a little axis of symmetry right through that. And the reason for that is, I know my parabola opens up because it's got a leading coefficient. And so I'm going to start here. I'm going to do a little dashed line here because I really don't know how low it goes. And I'm going to go back up. That's the sketch. And on Math Excel, you're going to have to identify which graph it is. You identify based upon the zeros. What is my y-intercept on this one? No, there's a y-intercept. On the y-axis, what is the value of x? 0. Remember, if I go up here and I put 0 in for x, what's going to happen? This becomes 0. This becomes 0. What's 0 plus 0 plus 28? Isn't your constant always your y-intercept? True or false? Yeah. So I know that my y-intercept's 28. So if on Math Excel they show me one, but 2 of them that cross at 4 and 7, then I have to start eliminating based upon the y-intercept. So that would be my next thing. Or based upon whether it opens up or down. So those are the kinds of things that you're looking to determine and eliminate answer choices. All right, so for number 2, we're going to change that. We're changing the function to read negative x cubed plus x squared plus 6x. So I want you, well, I'll help you do this one. So if we're going to find the zeros, I have to factor. What do I do first? Cube this time. Huh? Can I pull out an x from each one? Yes. What's my leading coefficient sign? Negative. Do I like leading coefficients to be negative? No. So we're going to pull that negative out along with the x, because it will make factoring what's left over all that much easier. So we have f of x is equal to 0. And I am taking out a negative x out in front of parentheses. So that means I'm dividing each one of these by a negative x. So this ends up with a positive x squared. X squared divided by negative x is a negative x. 6x divided by negative x is a negative 6 in parentheses. So then we have to factor that quadratic inside. So the coefficient of the x squared term this time is now positive 1. So I have a positive 1 times a negative 6 gives me a negative product, which means I'm subtracting the factors of 6 to find my middle term, which is 1. What factors of 6 subtract to give you 1? 2 and 3, don't they? And they give you 1. My 1 is negative, so the bigger of the 2 factors carries that sign. What does the 2 have to be? It better be positive for those 2 to combine to give you negative 1. Again, my coefficient from the square term is 1, so I don't have to use Greek convertage. But don't forget about the negative x. We have negative x and the 2 parentheses. The x squared becomes x and x. And then you have a plus 2 inside and a minus 3. Remember, at most, how many zeros am I going to have on this one? 3. So don't forget about the x. That's your biggest error, is forgetting about that x. So I'm going to set the negative x equal to 0. I'm going to set the x plus 2 equal to 0. And the x minus 3 equal to 0. When I solve this one for x, when I divide both sides by negative 1, what's 0 divided by anything? 0. Lots of you don't realize that. X is equal to 0. That's one solution. Then x is equal to negative 2 here, and x is equal to positive 3 there. So a couple things I know. I have a cubic function. It's got a negative original coefficient. So does that mean my right-hand behavior is going up, or is it going down? Down. So I know that my graph sketch should look like this, shouldn't it? And I know I'm crossing the x-axis in 3 places. So let's go ahead and sketch this. The only thing is I don't know how high or low my valleys, my relative max and mins are. So I'm going to plot a point at 0, a point at negative 2, and a point at positive 3. So based upon my previous sketch, my right hand starts down low. There's my arrow. I go up to a hill, back down to my other 0, down to a valley, back up to my other 0, and I'm Does the left and the right hand disagree? Yep. And the right hand is down or negative. It's good. It all looks good. There's my section. Any questions in general? Comments, concerns, problems? All right. So again, you won't be able to complete all of your homework because if you look at what's next, the only part that's left is this last page. I have not, well, this is kind of a repeat of what we just did. We'll talk about by graph here in a minute. Well, on Monday. We will talk about multiplicity. So if you see any questions dealing with multiplicity, you wait until Monday. Intermediate value theorem, if you were having to find the real zeros on something like this, did I teach you how to factor something like this complicated? Then skip those questions. Because even if you try to group in garbage, think about this. Those two have nothing in common, right? Those two have what in common? They have a 4 in common, right? If you take out a 4, you do get a 3 on this one, and they have an x squared also. If you take out a 4 here, are you left with a 5? No. So group and garbage is going to work on that one, is it? You don't know how to factor that one. And if you're not allowed to use your calculator, how are you going to find them? So we'll talk about the intermediate value theorem on Monday. So if you see anything ugly like that, skip it. And then what if I actually give you the zeros? There's 1 or 2 questions that are like that. Skip that one. But you attempt all the rest, and then you can ask questions on Monday.